class, this is our review on compound inequalities. So for number 1, with this setup, with the arrows pointing to the left like this is an AND compound inequality. So we're looking for x right now, and we're going to solve this inequality. We're going to get x by itself in the middle, so add 5 to both sides. Actually, all 3 sides, this side and this side over here. Using your number line or your rules, this is positive 3, this is x, this is 5. So now we have x by itself, and this is saying that x is greater than 3 and x is less than 5. So x is greater than 3 and it's less than 5. So it's going to be all the numbers in between here, greater than 3 and less than 5. Now we don't have an equal sign, so we're not going to include 3, and we don't have an equal sign, so we're not going to include 5. Okay, I'm going to have you do the next one. And, let's do the interval notation here. So the interval notation, the answers are in between 3 and 5. And I'm using a curvy bracket, or parentheses, because we're not including 3 and we're not including 5. So all the numbers in between there. Okay, let's do this one. You're going to try this one to get x by itself. All right, number 3, to get v by itself, it's being divided by 2, so we need to multiply this by 2. And multiply this by 2, and multiply this part by 2, and multiplying all 3 parts by 2. That cancels out the division, and so we get v is less than 0 times 2 is 0, greater than or equal to 2 times negative 2 is negative 4. So we get v is greater than or equal to negative 4, but less than 0, or and less than 0. So greater than or equal to negative 4, we put a bubble there, and because it's equal to, we can also include 4 as our answer. And then it has to be less than 0, so we put a bubble at 0, but we don't include 0 because there's not an equal sign. And we want all the numbers in between, all the numbers that are greater than negative 4 and equal to it, and less than 0. Okay, so our interval notation will look like this. We want to go from negative 4, including negative 4, comma, all the way up to 0, not including 0. And that's what your notation looks like. Okay, number 4, we're going to get x by itself, so we're going to divide everything by negative 4. Every part of the compound inequality. So this becomes negative 3. Now, what did we divide by? We divided by a negative, so that means we need to flip the inequality sign. Okay, so I have 3. I have to flip that inequality sign. Then we have, that cancels out, and we have x. And then we divide it by negative 4, so we flip, and this becomes negative 6. Now, if we're going to graph this on the number line, it's going to be tricky because we have the arrows, or the inequality signs, facing the wrong way. We want all the numbers that are less than negative. This says all the numbers less than negative 3 and greater than negative 6. Oh, we don't have a negative 6 here. We're going to have to add a negative 6. And if you can read it this way, then you could do it, but I prefer switching everything around, switch the whole thing, switch everything, so that the inequality signs are pointing the other way. So what happens is we get negative 6 comes first, then this is switched, then x, then switch, then this comes at the end. I switch everything, so it looks like this. To me, it's much easier to graph, less likely to make a mistake. So we want, this means the same thing, it's just written now so that we have the arrows, the inequality signs pointing to the left, like we have here, like we have here, like we have here. Okay, so x is greater than negative 6 and less than negative 3. We don't fill them in because we don't have an equal sign, and we want all the numbers in between. And then our interval notation is going to be all the numbers in between -6 and -3. Okay, those were some ands. And see how they're structured? Now we have some ors. So we need to solve for n on this inequality, or we're going to find the value that n could be in this inequality. So I like to just draw a line through here, and then I'm going to solve this inequality. So I'm going to add 3 and add 3. And we get n is less than -2. And then here I'm going to divide by 3, and get n is greater than 4. So, or n is less than -2 or n is greater than 4. Now this is going to look different than these graphs. These graphs are chunks or overlap pieces. These are not generally going to overlap. So we want all the numbers less than -2. So all these numbers, or all the numbers greater than 4. And that's what an or compound statement looks like. We have it going opposite directions. They generally look like this, separate. And you can make this, one of these numbers could be the solution down here, or one of these numbers can be the solution. Not both. You can't have and in here. You can't have a number that's less than -2 and greater than 4. That doesn't make any sense. All right, so then you're going to do this one, and you can just draw your line through here and solve for x and then graph. Okay, so our interval notation here is going to look a little different. I'll write it up here. It's going to be all the numbers from -infinity up to -2, or all the numbers from 4 up to positive infinity. So we're going to have two separate notations for this. Okay, so you're going to try this one on your own, and then let's look at, I'm going to do, I'll do this one. So here we have, this is written in the form of 3 inequalities, on one, all the inequalities are coming to the left, we have them all less than. So this is an and. So we're looking for the and for A. A is going to be greater than something and less than something else, less than or equal to something else. Okay, so we need to solve this. So we're going to subtract 1 from every section. That's -2 is less than -2A is less than or equal to -8. Now we're going to divide by a negative. So remember, when you divide by a negative, you have to be very careful here because we have to flip the inequality signs. So when you divide by -2, we get 5 here is greater than A here is greater than or equal to, and negative divided by negative is a positive, 4. So we get A is less than 5 but greater than or equal to 4, but I don't like it written like this. You could graph it from this. Some of you are pretty good at seeing it that way. But notice 4 is the smaller number, so it's better if the smaller number is on the left. It helps with the graphing. So I'm going to switch everything. Switch everything so that the smaller number is on the left. So 4, and then the arrow's pointing at the 4, so the switches, and this switches, and then you have the 5. So I switched everything around like a mirror, I guess. Okay. Now, these mean the same thing, but it's easier to graph when the smaller number is on the left. Okay, so 4 is less than, A is greater than or equal to 4. So here's 4, and we want 4 greater than or equal to. So A is greater than or equal to 4. It's going to go this way, but less than 5. So it's right in here. So this is the solutions in here. All the numbers between 4, including 4, and 5, but not including 5. So 4.1, 4.2, 4.3, all those numbers in there will be the solution to this. Okay. In this one, you're just going to get 2 inequalities, graph them down here. Okay? And it's an and. Number 9, this is an or. So I'm going to do this one. You're going to do this one. This one requires flipping the inequality, so be careful. All right, so let's see. Actually, I think maybe I'm going to let you do this one. And I'm going to do this one, because this one requires a lot of flipping. This one doesn't require any flipping. Okay, so these are ors. All right, I'm going to solve this one first by subtracting 5. We get negative 3m is greater than or equal to 15. Divide by negative 3, divide by negative 3, and we get m, and we have to flip because we divided by a negative. It's less than or equal to negative 5. So I did that one, okay? So m is less than or equal to negative 5, or, now you solve this one, and you're going to have to flip, like we did here, because you're going to end up dividing by a negative. So remember, you're going to have to flip that inequality sign. Okay, I'm going to let you finish that one. I'm going to graph this part of it. We want all the numbers greater than or equal, no, m is less than or equal to negative 5. So I'm going to graph this part. And the arrow goes that way. Now you're going to do this one, and you're going to graph it, and the arrow is going to go that way. And this one is similar to this one. You solve each inequality, and then you graph it. Okay, so if we add, I'll do this side. We add 2 to both sides. And you get 4x is greater than or equal to 8. Divide by 4, divide by 4, and you get x is greater than or equal to 2. So I'm going to put a bubble at 2, and we want all the numbers that are greater than or equal to it. Okay. Now you're going to do this side, and you're going to get some bubble here, and it's going to go that way. And it's going to go that way, to the left. You finish those two. Okay, on the back. This is a very tricky one. It has variables on each section, so these are very tricky. And these are ands. So the way these need to be done is you need to separate them. So I'm going to take 8 plus 2n and write it as less than 5n minus 7. And then I'm going to do this, separate this part. So 5n minus 7 is less than 4n plus 1. So I'm separating it. This part is greater than that, so I wrote that. And this expression is less than that, so I wrote it like that. See how those two things are coming from the middle? And then we solve each one of these and graph. This is and. Okay, so I'm going to subtract 2n from both sides. And we get 8 is less than 3n minus 7. And we're going to add 7 to both sides. And we get 15 is less than 3n. Then I'm going to divide by 3. And we get n is greater than 5. So n is greater than 5. So I'm going to put a bubble here. And you could switch this around so that n is on the left if you wanted to. Okay, you could switch it. Because the variable, it's nicer when the variable's on the left. So n is greater than 5. So I want all these numbers here. Now we're going to do this one. Add 7 to both sides. Actually, let's not do it that way. Let's subtract 4n from both sides. Let's get rid of the variables first. So that's 1 is greater than n minus 7. I'm going to add 7 to both sides. So n is less than 8. So we want all the numbers now that are less than 8. So we want this here and this arrow. So we don't want this part. We only want the part that overlaps. So we want the numbers that are greater than 5 but less than 8 right in here. And there's no equals, so we don't want to fill in these bubbles at all. Just this is the section we want, just this middle section in here. Okay? And this one is very similar. You're going to do the same thing. You're going to separate it out, and you're going to get an and, because this is an and format. M plus 8 is less than or equal to 6m minus 2, and it's greater than or equal to 2m plus 4. So and let's do the integral notation. 5 and 8. The numbers are between 5 and 8, not including 5 or 8. Now this is an or statement, so we're not going to get a chunk like this. We're going to get arrows going in the opposite direction. So we're going to solve this one first. We have variables on both sides, so we subtract 8n. We get n plus 7 is less than 3. Now I'm going to subtract 7 from both sides. We get n is less than negative 4. Okay? So n is less than negative 4 is going to be this bubble and all the numbers less than negative 4. And then this side, I'm going to solve again by getting rid of the variable on one side. We have them on both sides. Let's subtract this one. And we get 3 is less than or equal to n minus 3. And we add 3, 6 is less than or equal to n. Okay, so I'm going to reverse this around so the variable's on the, I'm going to switch it so that the variable is on the left. I like to do it in a graph. So I want all the numbers that are greater than or equal to 6. So I'm going to put a bubble on 6, fill it in, and I want all the numbers that are greater than or equal to that. So remember, when you have an OR, a lot of times the arrows go opposite directions. Now my interval notation is going to be, it goes from negative infinity up to negative 4. And here we go from, we go from 6 all the way up to positive infinity, and we include the 6 because it's equal to. Okay, that's the interval notation. This one's very tricky again. They're not really super tricky, but solve two inequalities and graph them. Okay, now a number is more than 2 and no more than 5. These you have to match up to these right here. And this is a challenge, but it's also something I need you to know. So a number is more than 2, but no more than 5. So that looks like this. A number is more than 2 and, okay, so it's going to be x is in the middle. It's more than 2 and no more than 5. So it's less than or equal to 5. Oh, no, it doesn't match that one. It doesn't match that one. It doesn't match that one, but it matches this graph right here. Look, it matches this graph. 2 is, x is greater than 2, but less than or equal to, so this is C. A number is less than 2 or at least 5. So a number, it says or. So a number is less than 2 or it's at least 5. So x is greater than or equal to 5. So x is less than 2 or it's greater than or equal to 5. Well, it's not that one, or that one, because those are all ands. It's not that one or that one, because those are ands. It's got to be this one, but look, it is. X is less than 2 or greater than or equal to 5. So this is A. Okay, here's number 17. A number is less than 5, but no less than 2. So let's look at this one. Number 17. A number is less than 5, but no less than 2. So the x is also not less than 2, so it's got to be greater than or equal to. All right, so how do we write this? X is less than 5, but greater than or equal to 2. This means and. So we're going to do it like this. X is less than 5, but greater than or equal to 2. I'm rewriting this to look like an and. Or you could just do it like this, and. But it matches this one, letter B. Okay, 1 less than a number is less than 5 and greater than 2. Okay, so 1 less than a number, the way we write that is x minus 1. We want 1 less than a number. That's less than 5 and greater than 2. This is number 18 right here that I'm doing. So this one matches, let me see this one, is less than 5 and greater than 2. So it should be, see the answer here. All right, I'm going to do the other ones and see if there's one missing. Okay, so 1 less than a number, so let's do 19. 1 less than a number is more than 2 and at most 5. So 1 less than a number, this is going to be an and. Okay, 1 less than a number is more than 2 and at most 5. And at most 5. So it could be equal to 5, but it can't be any greater than that. So this one does have an answer. It's letter F. All right, let's do number 20. 1 less than a number. This is also an and. See the and? Okay, 1 less than a number, minus 1, is at least 2. So it's greater than or equal to 2. And it's no more than 5, so it's less than or equal to 5. So that one is letter D. So which one didn't we use? A, B, C, D. We didn't use E. 3 and 6. 1 less than a number. Oh, I know why 18 is different. That's tricky. That's tricky. Look at number 18. 2 is less than x minus 1 is less than 5. If I solve for x, I get x is less than 6 and greater than 3. Oh, so that matches E. It matches the graph of E. That was tricky. Okay, and that's the assignment. I'll see you later.